Hello, class. So you've made it through Module 3, the research proposal. As far as the research proposal in that module, the focus was on the empirical methods of psychology. The empirical methods, of course, are very important to psychology. They are what distinguishes psychology from philosophy. While psychologists and philosophers may talk about many of the same ideas and theories, the difference is that philosophers rely on logic, while psychologists go further to empirically test that logic. Also remember that when Wilhelm Wundt founded the field of psychology, one of the primary reasons that he is considered the founder is because he conducted empirical research. So from this chapter, some highlights. Theory versus hypothesis. A theory is an overall explanation of a phenomenon. It's meant to be a broad explanation of a phenomenon from which hypotheses will be derived. It will be formulated. Okay? As far as a hypothesis is an educated guess. And in research, what is tested is that educated guess, is that prediction. Not necessarily the entire theory, because remember, theories are a broad explanation. So really, one individual study may not be able to, is not likely to be able to test an entire theory. Okay? So that's one point. Another point that I want to emphasize, and there were some additional readings on this, the importance of operational definitions. Okay? When you define how a variable is produced or set up, or define how a variable is measured, what you've done is provided an operational definition. For the producing or setting up, you've operationally defined your independent variable. For the measured, you're operationally defining your dependent variable. Something to keep in mind is that most psychological research, when operationally defining the dependent variable, focuses on quantification. What that means is obtaining some sort of number to describe that variable. So for instance, self-esteem as a dependent variable. Okay? As far as the assessment, the measurement of self-esteem, you can have subjects complete a survey containing many items related to self-esteem. Okay? Each of those items can be scored, and an overall score can be obtained on that self-esteem measure. Okay? So when you talk about dependent variables, again, in most cases, the focus is on quantification, coming up with some number for the dependent variable. Test performance is an example of quantification of knowledge in a course. Okay? So operational definition is very important. Okay? Another important element of research is the idea of sampling versus a population. When you conduct research, you have a sample of individuals actually participate in your research, but you want that sample to represent the population, meaning that the qualities of the sample, breakdown according to age and gender and so forth, are similar to the qualities or breakdown of the population. You want that similarity or that representative sample so that you can generalize your results from your sample to your population. Okay? So obtaining that representative sample is very, very important. Okay? As far as that representative sample, another issue that comes into play is related to the idiographic versus the nomothetic approach. The idiographic focuses on people as distinct, as unique from each other, whereas the nomothetic approach assumes that people are basically the same, okay? That you can get an average response and describe a lot of people. In most psychological research, the nomothetic approach is taken. And here's where quantification becomes important, because if you're going to describe many people, you want a number, you want an average performance. So if you're going to describe 500 people, it's very difficult to go one by one. That's where you get that average, okay? Again, a nomothetic approach. As far as yet another point, having in research both an experimental and a control group. This is when you do a formal lab experiment. You need that control or comparison group to determine whether your independent variable really had an effect. So for instance, if you're testing a new pain reliever to see if it alleviates headaches, let's say you give the pain reliever to a group, and let's say the group reports, yes, the headache was gone. But how do you know if you didn't do anything and the headache would just go on or go away by itself? Okay? You need that control group where you don't give the medication so you can have that comparison. Yes, the headache went away in your experimental group, the group that got the pain medication, and not the control group. Then you can say your medication is effective. So again, you always need that comparison group to see if your independent variable is having an effect. Okay? As far as 2 more points, one is the importance of methods of control in formal experiments. So in a formal experiment, one thing you do is you manipulate an independent variable, meaning you set up conditions to test your experiment. One group gets medication, one group does not. Okay? Other things you want to do is hold conditions constant. That's a second method of control, meaning that the other conditions in your experiment, other than that independent variable, are kept the same across both of your groups. That way you can say that it was your independent variable and not other differences in the groups that is causing the effect. Okay? And finally, the third method of control is balancing. Here's where, for example, you randomly assign your subjects to conditions. So that way you can say, well, okay, the severity of headaches, if I randomly assign people to different groups, then I'm going to equal out that severity. Okay? I'm not going to have in my pain reliever group only those with very mild headaches. Not if I randomly assign people. Again, those differences will spread out. Okay? And at the end of the experiment, what you can say, if there's a difference, you can say it was my independent variable, not pre-existing differences across my groups. So again, the methods of control in a formal experiment, manipulation of the independent variable, holding conditions constant, keeping things the same, and balancing. They are very important for you to be able to determine cause and effect, that in fact your independent variable caused the change. Okay. So finally, for this take-home point, correlation. And I end with that because correlation does not imply causation. Just because you have a relationship between two variables, so let's say as heat increases, aggression increases, that doesn't mean that it's a cause and effect relationship between these two variables. Doesn't mean necessarily that heat causes aggression. Okay? Another example of a real correlation is that as ice cream sales increase, so does aggression. Okay? Does that mean that we should not feed children ice cream? Of course not. Okay? Yes, there's a relationship, but there's not a cause and effect relationship. In fact, there's another potential cause, and that might be heat. Okay? So yes, there's a correlation as far as heat increases, people want more ice cream, and as heat increases, people are more aggressive. Okay? But you also get that correlation, ice cream and aggression, which would be known as a spurious correlation. It's there, but it really doesn't mean anything. So correlation does not imply causation. Just because you have the relationship doesn't mean it's cause and effect. Okay? Those are my take-home points for Module 3. And of course, I will have another take-home point video for our next grouping of modules.